Today is October the 4th, 2023. This is Addison Shonland, and Richard Sherman and I are going to have a conversation with Rod Williams, who is Chief Commercial Officer of Universal Hydrogen Canada Limited. Rod, it's lovely to have you. Thank you for spending some time with us.
Thanks very much, Addison. Good to see you both as well, Richard.
Thank you.
Okay, so I guess we should probably start our conversation with the general opener of, could you give us an update on the latest testing?
Yes, of course. So very recently, we had our 10th flight test, which was conducted out of our new flight test facility in Mojave back in June, I believe it was. We moved the aircraft from our previous location in Moses Lake in Washington State down to Mojave. And the main reason for that move was to get the flight test aircraft closer to our engineering facility, which is based in Hawthorne, California. So now we're only about an hour and a half drive away from our flight test aircraft. So that makes it quite a bit more efficient for our engineering team to work on the aircraft, do whatever modifications it is they need to do, and also to conduct the flight testing. So again, this was our 10th flight test. We had, I believe it was about 4 flights in Moses Lake before we ferried the aircraft down, which was a total of 5 different flights. We did it over 2 days, three flights on one day and 2 flights on the second day. And that last flight into Mojave was our longest flight ever, which was close to about an hour of flying. So in all of those flights, after our first flight back in March of earlier this year, the initial flights after the very first flights were simply to expand the envelope. We flew, for example, the aircraft up to 10,000 feet. We also expanded the envelope in things like doing full landing gear extensions and retractions, and same with flap extensions and retractions. And then we had the ferry flight. So our 10th flight, which was just over a week and a half ago, was the start of really our next phase of flight testing, which there's, I'll say, 2 primary goals, one of which is to continue to modify the aircraft to ultimately have it fly on liquid hydrogen. And our plan is to have the aircraft fly on liquid hydrogen in about the middle part of next year. So we're going to be working our way up in this flight test program to get to the point where we're flying the aircraft on liquid hydrogen. And then, of course, throughout this flight test program, we'll also be starting in parallel, we'll be doing work to help and support the certification efforts on our first STC program, which is the ATR 72-600.
Yeah. Can you explain a little bit more how you will transition from the gaseous to liquid hydrogen and then towards the certification phase, which is in 2025, if I'm correct?
Certification is in 2026.
26,
so,
yeah. So how many flights do you need until then?
Oh, it'll be to do the ultimate certification. It will be, I'll say, a reasonably extensive flight test program. It won't be as large as a new clean sheet design, of course, because we're just doing a retrofit on an existing aircraft. So we're not quoting publicly the number of flight hours that we're planning, but it'll be reasonably extensive, but not as large as a clean sheet design. So to come back to your first question, really it's, I think, pretty straightforward. Currently, we're flying the flight test aircraft on gaseous hydrogen using standard off-the-shelf commercially available gaseous tanks. And we are in the process of finalizing the build of our first prototype full-scale liquid hydrogen module using our own modular technology and capsule technology. That very first prototype will be completed very soon. And in fact, by the end of this year, our plan is to have that full-scale prototype running our Ironbird using liquid hydrogen. So we'll first, before we flight test, of course, we'll do some ground-based testing using our 1 megawatt Ironbird connected to a liquid hydrogen module of our own design. So really the transition is pretty straightforward, right? We need to complete the design of our liquid hydrogen module. There are some modifications that are required to the aircraft to to accommodate the flight test aircraft, to accommodate the liquid hydrogen module. And that's the work that we need to do between now and the middle part of next year, is to build those liquid hydrogen modules and also build the modifications to the aircraft to allow it to run on liquid hydrogen.
When do you expect to run on 2 engines that you're using hydrogen?
Yeah, so two engine flight testing will be part of the certification program. So that will happen in, I believe it's that will happen in 2025.
Yeah, and you are doing that with the Dash 8 300, or are you using the ATR?
So the flight test aircraft is the Dash 8 Series 300, but our first STC program will be the ATR 72-600. That's the one that we announced recently, that we had our STC application accepted by the FAA. We also, at the same time, had our G1 Stage 2 paper issued to us from the FAA, and both of those are pretty significant milestones in our certification program. So the ATR 72-600 will be our first STC program, and we're starting with that for, I think, some fairly obvious reasons. It's a bigger market than, say, the Dash 8 300 in terms of how many aircraft are in service today. It's also still in production, so the fleet size is ever increasing. And we just had stronger customer interest in looking at the ATR 72 than any other product. So that's been our priority for some time now.
If I'm correct, you have an ATR prototype aircraft in Toulouse that you're using for ground test system tests. Is that also the aircraft that you will use for flight tests?
Correct. We do have correct on the first point. We do have an ATR 72 test aircraft in our facility and engineering center in Toulouse. It has been used for engineering development and ground-based testing. So, for example, we used it to do a testing of our module loading concept of operations, in which, and there's videos on our website and YouTube channel to check this out, to basically unload and load full-scale prototype modules on and off the aircraft. So that was a test of basically the module logistics system. And the goal there was to improve our turnaround time estimates, which we were able to do. It will not be a flight test aircraft. It's not flight worthy. So we will be acquiring other aircraft for our flight test program.
Yeah, and how happy are you with the modular system when you are putting the capsules? Are you seeing leakage of hydrogen, or is that pretty good?
No, in fact, we're extremely happy with our liquid hydrogen development of both the capsule and the module. We've tested a number of different versions of our liquid hydrogen capsule, and all of the results have basically exceeded our targets and our expectations. So, for example, we've tested the heat flux, which is basically the ability of the capsule to retain or maintain the liquid hydrogen as liquid hydrogen, and we've been able to show that hold time or dormancy time of greater than 96 hours, which is far greater than we had originally estimated, and that comes down fundamentally to the design of the capsule and an extremely efficient thermal heat flux capability for the tank. And we've tested tested to other requirements as well too, including flow rate and heating up the liquid hydrogen to gaseous form, because the aircraft does need to see gas going into the powertrain, and all of the testing has exceeded our expectations.
Edison?
Thank you. I want to do, while we were on the business of hydrogen, can you talk to us about the hydrogen supply chain development? For example, everybody talks about, everybody wants to go green and net zero. Is the hydrogen supply chain development going as slowly as it is with SAF?
No, we're not seeing that. If you take a look at any of the surveys of hydrogen projects that are out there, there's really a very, very long list of hydrogen projects, hydrogen production projects going on around the world. So we're really not seeing seeing a lack of opportunity for hydrogen production or hydrogen offtake agreements, and quite frankly, that's globally around the world as well too. There are some regions that are leading. One of our key partners in the U.S. is Plug Power, and they have publicly announced a number of hydrogen production sites throughout the U.S. and they're already building them. So we really don't see that as an obstacle for us. And the question about SAF is an interesting and related one, particularly if you're talking about power to liquid SAF, because power to liquid SAF or PTL SAF actually starts with hydrogen, right? You have to produce the hydrogen and then you put it through a whole series of other processes to create the SAF. And we just don't think that that's anywhere efficient either from an energy or a cost point of view, because you're actually taking that hydrogen molecule and you're putting it through a number of other processes to create SAF. Fully understand that there's a need for SAF, particularly for longer range aircraft, but we believe, of course, that using hydrogen as the core energy source, whether it's fuel cell or combustion, is absolutely the right way to go. And in fact, it's really needed for us as an industry to meet our Paris 2050 goals.
You have, you mentioned in your press release last week, you have orders up north of 1 billion. I'm losing my contact, I think. I will continue here. And you have orders for 250 kits. How quickly can you produce these kits, and how do you expect this to grow into your aircraft business and for your customers?
Yeah, so we're not publicly announcing our production rates or our quantities, but we expect that there's an opportunity there because we're talking about a retrofit program, as opposed to, say, a clean sheet program for the uptake to be fair, and the growth in the uptake to be fairly rapid, once we start to get into production. So it was a bit of a landmark order for us to get to 250 conversion kits, and we're just gonna carry forward. But I do think that there's an opportunity for the uptake of the kits to be fairly rapid once we get into production.
And do you see difference in how hydrogen is developing? You said it's about even around to grow, but is the US ahead of Europe in this way?
I would say US and Europe are probably pretty much on the same path right now. There's many projects, as I said, that have start dates in the 24, 25, 26 timeframe. Many projects in both the U.S. and Europe for multiple uses, quite frankly, and that's the case in other parts of the world as well too. So there's some parts of the world where there's less hydrogen production, particularly in developing countries. But there are some developing countries, if I can put India into that category, for example, where they're actually promoting a very large hydrogen production ecosystem. So we expect to see that market to be, from a hydrogen production point of view, to be quite interesting as well.
Yeah.
Excuse me.
There are, of course, a few competitors. You have a competitor like Zero Avia. Airbus is in a kind also a competitor with Zero E. What do you see as the biggest differences in the technology these companies and yourself want to apply? Is it a different size of aircraft that you are after, or?
Well, so the Airbus Zero E program is a fantastic program, and obviously it's targeting much larger aircraft and a much different time frame. They're talking about the mid-2030s before service entry of any kind of product, and we're talking much faster than that. That's one of the reasons why we pursued the retrofit path. It's also the reason why we pursued a fuel cell powertrain path, because we think we're doing the largest aircraft possible using hydrogen fuel cell powertrain. Anything really larger than the ATR 72 it would require a combustion engine in order to be efficient from a weight and a size point of view. So we expect that the larger aircraft will need a combustion solution. which requires a dependency on the aircraft engine OEMs to create a hydrogen combustion engine, which many of them are starting to look at. But we didn't want to have to rely upon that development to pace our program, which is why we pursued a fuel cell solution with what we think is the largest aircraft possible in the ATR 72, and developing that powertrain ourselves. So, I think the speed of which we're doing things is one of the key differences, and we're also really doing the full package, if I can put it like that, right? We're providing a full solution, if I can call it that. We're providing a hydrogen fueling logistics and infrastructure solution, which is highly scalable, because we're using the modular solution. You can start service at a new aircraft simply by delivering filled hydrogen modules to that new airport and to that aircraft. And then, of course, we're creating the demand point, which is the aircraft itself, and we're developing both the powertrain technology as well as the engineering STC work to create that aircraft. So I think for me, those are some of the fundamental differences between ourselves and other players in the market.
Last question, Rod. If you look 5 years out, as best you can you give us a vision of how you see not just Universal, but the market generally evolving?
Well, I think it'll be a really interesting time, right? Because we'll be in service, and there will be hydrogen-powered aircraft that are flying in various parts of the world. Hopefully not just us, but others as well too. And I think our vision as well, in addition to getting our product into service and getting as many out there as we possibly can, is seeing the rest of the industry accelerate the adoption of hydrogen in aviation, whether it's ourselves or other aircraft OEMs, and you can list them all. But hopefully by then we'll have really seen an acceleration of the adoption of hydrogen as a fuel source in aviation. Because as I mentioned earlier, we really do believe that that's the only viable way for us as an industry to meet Paris 2050 goals. It won't be just on hydrogen alone. It won't be just on SAF alone. But we need both technologies to be in service and developed and up and running if we ever want to meet our goals. And it's a bit of an existential threat for the industry, because if we don't have those solutions in place, it could very well be that by years from now that aviation will start to effectively get legislated out of service, because we simply can't stand being an ever-growing part of the problem if we're not able to introduce these types of solutions.
And do you expect OEMs to adopt your technology in, let's say, the 5-year horizon, and that they now take a wait-and-see approach to see how you develop, how you certify before they might adopt it? For example, referring to ATR.
Sure. I mean, our goal is, particularly with our modular technology, or maybe even with our powertrain technology, but with our modular hydrogen technology, our goal would be to have other companies adopt it, because we think it's the best way forward, the most scalable way forward to provide a hydrogen refueling solution. One of the fairly public collaborations that we've had was with Deutsche Aircraft to evaluate our modular technology on some of their aircraft variants, and in that case, they were and are working with other powertrain suppliers, which is totally fine with us. We're happy to provide our modular technology to other OEMs, then have it adopted on clean sheet or other types of design. So sure, that's a vision that we would like to see play out as well.
Thank you so much, Rod.
You're very welcome. Thanks for your time.
Thank you.